So in this video I'm going to discuss Codeforces round 948 rated for division 2. So I will be solving first three problems in this problem set. So let's start with problem A, that is little Nikita. So in this question we are given a boy and he has some number of cubes as a present and he want to build a tower out of them. So tell whether it is possible or not. So he will be given total number of n cubes, total number of m cubes, and he want to build a tower of size m in from that. Or what he can do, he can either put exactly one cube on the top of the tower, or he can remove exactly one cube from the top of the tower. So whether it is possible to make total to make a tower of size m with total n number of moves, print yes or no. So the answer is pretty much simple. If your number of moves are equal to the height of the tower, then answer is yes, because he can put one tower, one cube on the top of each other and simply reach his goal m. Or you can also say, if if the height of the tower is greater than the number of moves, this answer is simply no, because he cannot make that much amount of height of tower. But if your height of tower is smaller than the number of moves, then answer is yes. If and only if difference between both of them is odd, then answer is no. If difference between both of them is even, then answer is yes. But why? So let's suppose you are total having a cube. Let's suppose this is the tower. Okay, so this is the tower. Great. So if the now you tell me whether it is possible to make a tower of height, let's suppose 1, 2, 3 and 4 in total number of n moves. Yes, it is possible, but how? You can only say by you will first of all put each and every cube on top of each other. Okay. Now you will again put a cube on of this. Now you will subtract this cube. So tell me how many steps have been performed. Total number of steps performed are m and Rn, and total number of or total height of steps, total height of tower is m. So answer is yes in this case. So if I repeat it again, if the difference between n and m is even, then answer is yes, else answer is odd, because you can always subtract the difference divided by 2, because in some number of steps you will try to build the height, you will try to increase the height of the tower. Okay, suppose this is the extra one, then the next n steps you will try to remove them, the extra steps. So total number of steps required will be even only, because half for adding and half for removing. So this is the question answer. So let's now discuss the next question, that is binary coloring. So this question was very much interesting. So in this question you are given a number x. Okay, you are given a number x. What is a number x? For example, this is a number x. Okay, so you have to generate a binary string of this number x. But there is a condition that for each and every binary string you can not only print 0 and 1 but also minus 1, and minus 1 represents, for example, this is a binary string. Okay, for example, this is a binary string. Okay, so you know one thing like that. For example, if this is this is a one string, then the corresponding added answer would be 2 to the power 1. Okay, and for this would be 1, 2, uh, 3, 4, 5, that is 2, 2 to the power 5. Okay, great. But you are now also having minus 1. Here minus 1 will represent 2 to the power 6 and in the minus. Okay, so this is the minus 1 represents. So you have to represent the number in form of these numbers. Also you have to make sure one thing, that if you pick any of the two consecutive numbers, then one of them should be 0. For example, you can see, if I choose these two numbers, then this one is 0. If I choose these two numbers, then both of them are 0. But if I choose these two numbers, then you can see none of them is 0. So the answer is not valid in this case. So how you can solve this problem? So the answer is very much simple, but why? So first of all, you have to represent the number in the normal binary string. Okay, I will tell you why. This is a very nice observation in this question. So the string the x is 14. So what is the binary representation of 14? That is, I think so, 0, 1, 1 and 1. I think so, 2 plus 4 plus 8. Yes, I think so. This is 14. So the binary representation of 14 is 0, 1, 1, 1. So how you can break it? But you know one thing, this is not a valid answer. But why? Because here you can see this pair. If you pick this pair, then both of them are 1. Okay, so if both of them are 1, the answer is no. the answer cannot be possible because one of them should be 0, because one of them should be 0. If you pick these two numbers, you can also see both of them are 1 and one of them should at least be 0. So answer is not valid in this case. But if you try to break up the problem, let me take you one case. Like for example, if you're giving a consecutive strings like this, okay, then you can easily make them in a acceptable form. But what is acceptable form? The acceptable form is simply that the sum of all these numbers should be equal to the next number which I'm generating, next binary string which I'm generating. For example, what is the number representing at this set? That is 2 to the power was 0, 1, 2, 3, 4, 5. That is 5, which means 2 plus, I think so, 1 plus 2 plus 4 plus 8 and plus 16, and whatever this number would be, your final number. Okay, so you can also represent this number in a new form. And what is that new form? That is minus 1 and 0, 0, 0, 0, 0 and 1 extra in the end. So you will notice one thing, that this is a mapping. That first number representing by minus 1 and rest all this number would be representing by 0, and you will add an extra 1 in the end, which means this new equation will have a size plus 1 from your original string, and the sum would be same. Okay, but how? What is the sum of this? Maybe you have calculated till now. That is 3 plus 7, 7 plus 8, 15, 15 plus that would be 16, it would be 32. Okay, now what is the sum of this equation? That is 64. Okay, I guess I am wrong. So it will be 3 plus 4, 7, 7 plus 8, 15, 15 plus 16, that is 31. Yes, it is 31. Okay, great. Now what is the number representing this? So you know the number representing this would be 31. Okay, 32, sorry, because the number, because one at this position represent 32 and minus 1, that is minus 1, because at 0th position with this is 2 to the power, I think so, 6 minus 2 to the power 0. Okay, that is equal to, sum of 2 to the power 0 till 2 to the power 5. So this is the main equation you have to keep in mind. Okay, if I generalize this equation, that will be the sum from 2 to the power I till 2 to the power I mm, plus k is, this is a sum, I think so, this is a sum from this to this. This is not minus, this is sum from 2 to the power I to 2 to the power I plus k, that is equal to minus, this is minus 2 to the power I will make in a bracket, minus 2 to the power I plus 2 to the power I plus k plus 1. Okay, so this is the main equation you have to keep in mind. Okay, I will add a summation here. Summation from 2 to the power I till 2 to the power I plus k is equal to minus 2 to the power I plus 2 to the power I plus k plus 1. But how to utilize in this equation? So let me get back to this test case. So you can see these are the three consecutive ones. So what you can do, you can simply write in the form of a good manner, that is 0 and minus 1 here, and 0, 0 and 1, and this number is also representing 14 only. But I can calculate also, that is 2 to the power 0, 1, 2 to the power 0, I guess, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, that is 16, and minus what, 2 to the power 0, 1, 2 to the power 1 is 2, that is minus 2, that is equal to 14. Okay, so this is the main equation to keep in mind with solving this problem. So let me generalize the solution. So let me generalize the solution. First of all, find the binary representation of that number. Okay, for example, if this is your number x, find its binary representation. Okay, okay, great. Now in that binary representation, for example, you are having a this binary representation. Okay, great. That is 0, 0, 1, 1, 0, 0, 1. So what you have to do, if you are encountering consecutive ones, then simply replace it with minus 1, a number of similarly 0 and a single one at the end. Okay, similarly for this, that will be minus 1, 0 and 1. Okay, great. Simply this will become this will become this, and number of zeros would remain same in the end, that is 0, 0, and this is 0, 0 and 1. So this will be the final string look like, and you can always see using this method you will always get the at least 1 0 in any two adjacent pair. So that's how you can solve the problem B. So let's now discuss the problem number C, that is Nikita and LCM. So in this question we are given an array and we have to find the maximum length of subsequence in this array such that the LCM of that subsequence is not present in this array. So how to solve this problem? So I will tell you this question with respect to my code. Okay. Uh, Let me resize it. Okay, great. Okay, so where is my code? You can find the code of problem will be here. I will pin it in the comment section. You can see the code is very much small. So let me explain it also. So if you're encountering consecutive ones, then simply replace the first one with -1 and rest all with the a 0 and simply add 1 in the end, and simply this is the answer, and print the size of the string, size of the final answer, and output it. Okay, so this is my code for problem number C. So first of all, what you have to do, you have to find the LCM of a whole the string. Okay, first of all, find the LCM of full string. For example, if this is my string, I'm taking this as a test case. Let me take a smaller one. Okay, okay. So first of all, find the LCM of the whole string. Okay, so done. Let me find the LCM. So what is the LCM? I think so LCM is 60, no, 60 only of this. So if you notice one thing, that if your LCM is not occurring, if your LCM of whole string, if your LCM of whole array is not occurring in the array itself, then answer is simply n, because that is the maximum possible subsequence. But if there is a case that your max LCM of all the numbers is occurring in your array, then you have to think of the answer. But why? But how? First of all, find all the divisible of your LCM, that are 2, 1 also, 3, similarly 4, I think so 4 would be also there, and 5 and 6, I think so 10. Yes, 15. Yes, 15 also. And 20. Yes, 20. And 30 also. Yes, 30 also. Okay. So these are all the divisor of your LCM. Okay. You can see in the code what I am doing. First of all, I am checking if your LCM is not there in your array. Or you can see, you can also notice if your LCM is greater than 1 in 9, then answer is simply n, because the limit of your array is only till 1 in 9. If your LCM exceeds 1 in 9, then you're absolutely sure that LCM is not occurring in your initial array, and simply print answer as an n. Now what you will do, you will find all the prime divisor of your LCM, that is here, but I am listed here. Okay, now sort them in a reverse order, which means you will start iterating in this array from right to left. Okay, from left to right to left order. Great. Now what you will do, you will try to find whether your current number exists in your array or not, whether your current number exists in your array or not. If it does not exist, if it does not exist, then you have to do operation. But what is that operation? For example, if this is 30 and 30 does not exist in your array, then find all the divisor of your 30, that is 3, that is 2, and that is 10, I guess also. Okay, so these are all the divisors. Now check, then find the LCM of this. The LCM of this, I think so 6 and 60. Yes. And now try to find whether the 60 exists in your array or not. Yes, 60 exists in this answer, in this array. Now this is what I'm doing. If your divisor does not exist in your answer, in your array, then find all the divisors of that number and find that LCM. If the LCM exists in your in your array, then continue. Else, this could be one of your maximum subsequence. Okay, so this is what I'm doing here. First of all, finding that number which is not in the array. Then what I'm doing, if my LCM, you can see if my LCM is not in my current array, and what is this LCM? This LCM is the LCM of all the numbers which are divisor of my that number which is not in the array. Okay, let me repeat again. This LCM is the LCM of all that numbers whose are divisors of that number that is a divisor of your LCM of your whole array and not present in your nums. Okay, I hope so it is now clear to you. If it's not there, then this could be your one of the answer. Great. Now 20. Now move there to 20. Now 20 is there. Yes, 20 is there. Then leave it. 15. Is 15 there? No, 15 is not there. Now find all the numbers which are dividing by 15. That is 3. Okay, great. Is there any more number? 1 also. You can also write 1 here. So 3, 1. Is there any more number? No. So you know one thing, that 3. Is there 3 present in your array? Yes, 3 is present in my array. So no, no for this also. Now for 10. 10 is in your answer. 10 is in your array. Okay, great. Mm, what is it test case like? Mm, I think so for 30 there could be one more test case, I guess. Okay, sorry. So the LCM of this is not 60, it would be 30. My bad, my bad. So this is 30. Okay. Now notice one thing. Is 30 present in your array? Not. 30 is not your not in your array. And you know one thing, that LCM of all these numbers is 30 and 30 is not in this array, which means this subsequence is one of your answer, which means 4 can be your answer also. Now for the next divisor, that is 10. 10 is in your array. Yes, 10 is in my array. So cut it, which means you will not traverse for it. Similarly, you can cut for 20 also because you haven't traversed. Now for 6. Now for 6. What are the divisor of 6? That is 1, 2 and 3. Okay. Now its LCM is 6 only. Now you one thing. Now you know one thing, that 6 is not in this array. That's why I'm traversing it here. Now 6 is not in this array, which means my 3 can be answered. But my 3 would you take 3? But no. But why? Because you have gotten a maximum answer as 4, which means if you're getting an answer greater than 4, then only you will update 4 of your answer. Then 5. Similarly for 5. Now you will notice one thing, that for 5 only 1 is there. So no, not for this. And for 4 only the answer is 2, because this divisor is 1. Here divisor is 1 and 2. Okay, the size is 2, the size is 1, not greater than 4. Size similarly for 3. 3 is there, so similarly cut it. 2 is there, cut it. 1 is there, cut it. So the only nominations, I can say nomination. So only nomination for the largest subsequence are only at 4 numbers, that is 4, 5, 6, 15 and 30. And among these nominations, 30 is generating a highest possible length, that is length 4. So that's why the answer is 4 only. So that is how you can solve the problem number C, and you will get the code in the comment section. If you have any doubt in any of these three problems, you can comment me down. Until then, stay tuned for the next one. Thank you.